Okay, this morning we're going to go through acids and bases. Now, we're going to do quite a bit with the math of acids and bases later in the course. So right now we're just going to do an introduction because we're just tying up some of the grade 10 stuff. So acids and bases, or pH, gets its name from a Dutch term per for concentration. And what it's talking about is the concentration of what's called hydronium in solution. So we're going to go through all of this. But the acid-base scale, or pH scale, is sort of interesting in that the middle is neutral and the scale works out from there. So things get stronger as you go to the end. So they start weak and they get strong. So both acids and bases are corrosive. So if we took a strong base and put you in a strong base, it would be corrosive. If we took a strong acid and we put you in that, it would be corrosive. Now here's the interesting thing about the pH scale. You figure if we throw something in your eyes that has a pH of 1 that it would burn your eyes out. But this scale is only for common items. So really strong acids and bases are not on this scale. So I have items in my lab that are 210 times stronger than anything on this pH scale. So this pH scale is meant for common everyday items. So maybe like food items, many food items are acids because they have things like citric acid or malic acid in them. A lot of your bases are cleaners. Okay, so if you have a candy and it's sour, that's probably due to the fact that you've got an acid in there. Bases will be bitter in taste, like coffee. Sometimes people are confused by the fact that bases are slippery, but think about it. Soap is a base. If you rub soap on your hands, it's slippery. I've spilled strong base on my hand before, and before you feel the pain, it feels slippery. Now, this is an acid, and what makes something acidic is it gives up a hydrogen. So the HCl is able to release that hydrogen. And what it does is it forms with H2O to form something called hydronium. So this is what's actually acidic. The acid itself is not acidic. It's not until it mixes with water until it becomes acidic. So a good common example of that are onions. So if you take an onion and you cut it open, the reason that you cry is that the SO2 that is in the onion gets in the air, it gets in your eyes and it mixes with moisture in your eyes and it makes H2SO4. Okay? So the hydronium is the acidic portion. If you've taken a biology class, the teacher might use the short form H+. H+ doesn't really exist. H3O+ is what exists. So this is an acid. A base would be like NaOH. So where the H is the acidic portion, the OH is the basic portion. And when it breaks down, you get H plus OH negative. So this is the base, and this is the actual acid right there. So it's hydroxide and hydronium. Hydronium, acid, hydroxide, base. Interestingly, what happens when you mix acid and a base together? You get water, you make something neutral. So if we take HCl, this is our neutralization. If we take HCl and we mix it with NaOH, so this is an acid and a base, and I do this in the lab with the kids, what happens is it's a double displacement. So the Na goes with the Cl and the H goes with the OH. So what you end up making is salt water when you neutralize something. Neutral is that middle of the scale, that's 7. So distilled H2O is a good example of something that's neutral. Now, let's take a quick look at how the scale works. This is a log scale. What does that mean? If we go from 4 to 3 to 2 to 1, we're getting more and more acidic. Every jump on the scale is 10 times different in strength. 10 times is a huge difference. So something that's a pH 5 versus a pH 1, that is a big difference. If you jump 2 places on the scale, you've got to multiply the 2 numbers together. So it's 10 times 10 equals 100 times. If you jump from 4 to 1, it'll be 10 times 10 times 10 is 1,000 times. Some basic naming. So, strong acids. There are 2 types. There are binary acids. Binary means 2. That'll be hydrogen plus group 7 elements. Hydrofluoric acid is not strong. These ones are. So the way they're named is that would be hydrochloric acid, hydrobromic acid, hydroiodic acid. Okay, the other type of strong acid is an oxy acid. And these occur when you have polyatomics with the hydrogens, but only certain polyatomics. So for example, you need to have 2 more oxygens than you have hydrogens. So you've got 1 hydrogen, you've got 3 oxygen, 3 is 2 more than 1. So if you don't have at least 2 more oxygens than hydrogens, you can't have a strong acid. So we would name these things like nitric acid and sulfuric acid. So strong acids are either a group 7 element in hydrogen or a polyatomic and hydrogen. If we want to name a strong base is a group 1 or 2 metal plus OH. So this would be sodium hydroxide. Folks, I believe that is all the information that you need to know for acids and bases at this point. You are going to have a gizmo that will have been explained to you, and you'll have to hand that in. And this afternoon you have a unit test with about 30 to 35 marks on it.